So basically, this is question number 4. For question number 4, is the continuous function f is defined on the interval from -4 to 3. The graph of f is consisted of two quarter circles and one line segment, as shown in the figure above. Let g of x be equivalent to 2x plus the integral from 0 to f of t d of t. So, for part A, what we have to find is we have to find the g -3, we have to find g prime of x, and we have to find g prime of -3. In order to do that, I followed these simple steps. So to start off, I chose to find g prime of x because I feel as if that's the easiest point to get. So in order to do that, all you have to do is just take the derivative. So the derivative of 2x is 2. The derivative of the integral of f of t d of t is f of x. The reason why that's f of x is because the derivative of an integral, they cancel out. So what's left is whatever's in the middle. And we know that f of t is assigned in the middle. That's the point right there. Then the second point is I did g negative prime of 3 because we already found g prime of x. So all we have to do is just plug in -3. So you would get 2 plus f of -3. And looking on the graph, we know that f of -3 is 0. So that will give you the answer 2. So we already had 2 points here, but remember we have 3 different things that we had to find. So the third point is going back to the original equation is finding g of -3. So plugging in -3, you would get 2 times -3 plus the integral of 0 to -3 f of t d of t. And in order to figure out the integral of 0 to -3 f of t d of t, you would just have to take the area from 0 to -3, which will get you a -9 pi over 4. And we already know, simplifying this, you will get -6, and that would be your answer. Okay, now, so for part B. For part B, it says the absolute max from -4 to x to -3. We have to justify. That's going to be its separate part. So not only are we getting a point for finding the absolute max, but we're also getting a point for the justification. So to start off, what I did was I took the derivative of the original equation to get 2 plus f of x. Then from there, I put g of x is equal to 0. From there, I know that's important because I know before that, it has to be some sort of change, and after that, it has to be some sort of change. So overall, the sign is changing at that point of 0. So, figuring this out, I know -2 is equal to f of x. So that means that if you look on going on the graph, we have to create a line at -2. Creating a line at -2, we're able to see an intersection within the slope that we have. So from there, we have to look at the x-coordinate. Looking at the x-coordinate, we know that it's 2.5. Or if you want to use it as a fraction to make it better, it'll be 5 over 2. Right. So now we got the point, not the point, but we got up to the point of figuring out what 0 is. F of x is at 0. And we also figured out the graph. So then, from there, all we have to do is just explain. So we know that g prime of x is greater than 0 on the interval of f of x of 5 over 2. And g prime of x is less than 0 on the interval from 5 over 2 x to 3. So the absolute max is at that point because we know that there's a change in the slope. It's greater than 0 from one intersection and it's less than 0 from that other intersection, but I know that at that point, at 5 over 2, it is 0. Alright, so now we're on to part C. So for part C, what we have to do is we have to find all the values of x at the point of intersection. We also need to justify. Keep in mind, like I said for point B, you're going to get a point for finding the point of intersection, but you also have to have a point for the justification. So to start off, what I did was I took the derivative. And then from there, I already know that the derivative of g of x is g prime of x, which is 2 plus f of x, but I have to take the derivative again because we know that the point of intersections is where concavity goes from a concave down to concave up, or concave up to concave down. So we know that g prime of x is equivalent to f prime of x. That is very important because I know to look for when the slope of x changes in order to find the g double prime of x. So going on the graph to look at that, we know that the point of intersection is at 0 because that's the only point where the slope actually changes from a positive slope to a negative slope. Anywhere else on the graph, there is no actual change like that. So all we have to do is, since we found this point, we just gotta explain what I literally just said. So since g prime of x is equivalent to f prime of x, we need to look for when the slope of f changes slide, which is only at 0, which makes 0 the point of inflection, sorry. Okay, so the last question that we have right now is the average rate of change from -4 to 3. So to start off, all we have to do is just use the equation for slope, which is y of 2 minus y of 1 is over x of 2 minus x of 1. So plugging in -4 and 3, we know that we have to start off with f of 3 subtracted by f of -4. After we do that, we have to take the x values and place them at the bottom as well. So it'll be 3 plus 4. The reason why it already has the pluses over here, because I know that it was originally 3 minus -4. And we know that 2 negatives is equivalent to a positive. So, at the same time, figure this out. For the top two, all you have to do is just look at the graphs. Those are easy points right there. Our overall answer will be -2 over 7. After we do that, all we have to do is just explain exactly what I wrote. But we know that f is not differentiable at x is equal to -3, which is 0. So point C does not exist. Point C does not exist. And then after writing that out, we know that we got that point from here and we got the point from here, and we just did an amazing job.